Am I live? Hi, I think I'm live. So, this is cool. I think my, oh, yeah, good. We have, yeah, good sound. We have, yeah, good sound. We have, yeah, good sound. Oops, I'm got myself in a little loop there. And, cool. So what I want to do today is kind of work on, this ABI stuff. And last time, well, I've been offline for a little bit because I've been jet lagged and, you know, having a life and all that. But anyway, um, last time I fixed some tests and then I promptly went and broke them in this commit because I was allocating too much memory and now I seem to be allocating too little memory. Go figure. So what I think is going on here, let me keep this open so I can see if my video is okay. Okay, there. Oops, fuck. No, stop. Is that visible? That's nice and visible. Okay. So, I think what's going on is when we, in the old code, sure, let's push whatever I have. In the old code, whenever we ABI encode stuff, whenever we ABI encode stuff, it's like got all these offsets, which is good because you want, you know, you want to allocate enough space for your byte strings. Function, no, parser, function definitions, there we go. And we maybe so I know there is something in here that I'm looking for. But basically, here, oh yeah, it uses this thing. It uses get size of type, and for this it allocates an extra word, which is real handy because in Vyper memory, bytes are represented as like a word for the length and then, you know, the bytes. But in the ABI encoding, you usually are returning bytes from a function, and then there it's like a one-member tuple. And so you need a word for the offset, a word for the length, and the bytes. So like for memory byte arrays, this is allocating too much memory, but for like ABI encoded byte array things that you return from functions, this is allocating exactly the right amount of memory. But when I wrote the new, where are we going? Oh, we need to check out this stuff. When I wrote this, we're like probably not allocating enough memory for the byte arrays, which is a little bit sad. But anyway, this is all kind of speculation because I just reduced the amount of memory that was being allocated and everything broke. So what I want to do today is like kind of dig into this and find out what's going on. So I wrote this little contract, which is taken directly from the test suite, and array. Okay, so method identifiers foo.phi, you know, and we've got test as f88, fd60, something like that. So we run that, and oh shit, sorry, this is supposed to be G-rated. Really? Did I? Did I break it? Is that what it was? How do you do inline comments in Bash? Wouldn't you like to know, Charles? Can I do it like this? No way. No, definitely not. Okay. Okay. If you want to know why that works, or read Stack Overflow. Anyway, moving on with life. Got a little. Oh, maybe I should commit that. Oops. Fix the comments and run Vyper. Okay. So now we run this thing. Oh, I'm sorry, you can't see my screen. Uh-oh. Okay. Moving here. And we've got a run. And I want to spread this out a little bit so that, okay, that works. We got a stack underflow. So sad. That means we don't have enough lights. So let's do some really horrible things for a minute and see if it works. So let's just add 32 and see if that fixes the thing. Oops. Make and do that. I just wanna be somebody, someone, oh, be somebody, someone. Oh, shit. Hey, I think that did what we wanted. So just to double check that it did, I want to run this test. I test this thing. And that should pass. Why would that 32 bytes make such a difference? Oh, nope. Did not pass. Definitely didn't pass. That's no passing for me. No stack items. Thanks. I think that has 2 byte strings, so probably wants like This is going to be really terrible, but I just want to find out exactly how many bytes we need in order to make this pass. You can see I'm very distracted by my phone. I have a life. Oh, anyway, that made everything pass. Sad. Sad face. I guess we might as well just keep doing this until we accidentally get the right number. Yeah, 128 was a good number. Maybe we'll find out if 96 is the right number. Six is a better number. So, because I don't really understand what's happening yet, I want to run this code and see what it actually returns. And this says return starting from 300 160 bytes. Okay, where's 300? Probably everything we ever wanted is right here. So we're returning an int, 128, an address, and a bytes. And the int is 1. Okay, we got one of those. That's right there. The address is 0. We've got one of those. Okay, now this is the interesting part. I'm sorry. So let's say 160. Sorry, divided by 32. It's 5 words. Okay, so we've got 1 word, 2 words, and then 3 word, 4 word. What? We're not even returning enough words. I mean, we don't even have allocated enough words. Let me count again. 1 word, 2 word, 3 word, 4 word, 5. Oh, yeah. So we're good. Okay, so forget the first word, forget the second word. Third word, that says offset is 3 words from the start of the ABI encoded section. Good. And then we've got a byte array of 6 elements, and then we've got the byte array data. Oh, actually, I would divide by 32. Anyway, so there must be something wrong with how I'm calculating how many bytes it needs. Okay, and ABI bytes needed. You know what this probably is? This must be the same shit as this other bug that I found over here, where for dynamic data, static size is super wrong. Yeah, that's gonna be really wrong because, like, here we're like returning a tuple, you know, address, int, bytes, or whatever, and the static size of that. I even wrote notes to myself about this, which is that it's the size when it's embedded in a tuple, and is like not generally correct. So like for class ABI tuple, the static size is going to be 32 if it's got any dynamic data in it. And I left a note to myself, perhaps this should be renamed static size in parent, because of course. So maybe I need a function that's like static size as parent. Or maybe def ABI bytes. And this is going to return something that we want. You know what, I'm going to make this new function, and I'm not going to worry too much about what I call it, because, you know, maybe I'll call this, like, I don't know, embedded static size, or something, and this is going to be static size. But for now, I'm just going to call this static size 2. And this is just going to return some t.static size for t Actually, this isn't going to solve my problem, is it? Because no, that definitely solves my problem. But it's kind of confusing because it's going to dispatch to static size, embedded static size. Whereas for a byte array, it's going to just return, it's going to dispatch to something else. Okay, anyway, let's just implement it this way. Def static size to self raise bytes of the static section. I mean, this doesn't even make any sense when it's not a tuple. Sorry, I'm pretty distracted. But anyway, that's what we're gonna need. And then for gint and it's gonna return the same as, you know what? I'm gonna cheat. I'm just gonna return self.static size for the most part. And then we'll just fill in the exceptional cases. And the only exceptional case is tuple-like things. If self.is dynamic, else 0. I don't. This is gonna return not the right thing too, because of the fact that bytes in return data is always gonna be a one element tuple. But we can fix that when we actually implement ABI encode, which has to distinguish between raw byte arrays and byte arrays embedded in tuples, but for now we'll just have an extra word. For raw. Bryant doesn't like me leaving to-dos in my code, but whatever. For function orange returns, this is correct. Okay. And okay. Now we just need to find the exceptions, and I believe the only ones are going tuple and static array. I think this is even wrong. Return 32 if self dot is dynamic, else this shit. And then def static size 2 self is going to be return self.m elements times self.subtype.static size. So what I'm seeing is that really it should be the other way around. Static size should be defined in terms of static size 2, but let's not get too hung up on that. Just and then I think this is just gonna do exactly what we want, except now we can fix this ugly sum. Dyn section 2 equals ABI type of O.type. I'm pretty sure I already calculated what the ABI type is. Didn't I? ABI type of O.type. What is O? Who wrote this code? Oh, I see. I'm in the middle of writing this code. Parent ABI t dot static size 2. And who thinks that this code is going to work? I'm taking bets. Hey, that worked. Fascinating. Well, I guess for shits and giggles, we'll push this code. Fix static size calculation for tuple things. Tuples and fixed arrays. Okay, and I wonder if we need to like rebase ever. And let's see, I should look at this. Is that supposed to be offset? I think offset is a pretty standard abbreviation for offset. Sure, but it only saves like 2 letters. Can you even see this? Yeah. I'm just going to resolve that. Move on with life. Because everybody knows that offset is spelled OFST. Can we see what is running? No, that's not something that's available to us. I guess we could see where we branch with master. Ooh, that's pretty far. I'm not sure I want to like actually rebase at this point, maybe sometime in the future. So I guess the other thing I wanted to do today was work on these return things. But maybe I'll come back to that later in another session. Yeah. So for returners, when you return a byte array, you have to find its offset. Da 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 da. So what I want to do here is replace this code with ABID code. Contract call output. Oof. And we just assume that, you know, it's gonna work out, I guess. The thing that confused me about this is why we need a new placeholder. Because why do we need to allocate memory when the memory should be already allocated? Oh no, that allocates the memory so that it can get written to. Gotcha. Well, what we really need to do is we need to allocate the size of the ABI encoded payload here. Then, you know, call the external function and it'll write into that buffer, and then we lazily decode the output, the ABI encoded payload. And there's something really interesting going on, which is that for byte arrays, they're always, I keep talking about this, but it's kind of like really got my attention. For byte arrays, they're like an element of the tuple. Oh, hey, look. The test passed. That's incredible. Hallelujah. Okay. I kind of want to find out how certain things are encoded. But what happens if we just So this is going to be an address, right? What if instead we return our lazily decoded thing? Okay, context, new placeholder. Sig.output type. See, we don't really want a placeholder because that's not low level enough for this. New internal variable runs increase memory. What we really want to do is just put placeholder nothing equals context dot memory allocator dot increase memory size. And of course the output size is going to be not this. It's going to be ABI type of output type. ABI type of sig.output type dot output ABI t equals ABI sig.output type. And we're going to grab output ABI t, and because I can't remember what I did 3 minutes ago, we're just going to look it up. Static size 2. Oops, wrong file. Static size 2. That's exactly what we need. Okay. Yeah, I like the variable name ABI type. Okay, good. And then we're just going to say returner equals ABI. No way is this going to work. I mean, I wrote it to work, but context that statement. I don't know. No, I don't think that can be right. We'll just leave the position out of here for now. And see if this works, I guess. There's no way this is gonna work. We actually don't need to return the returner here. We can just calculate it outside. But for simplicity, we're not going to do that for now. Actually, I don't want to run this on my local computer because it's not going to work. So we're just going to use the remote CI. I'm not sure that I did a session for my lazy decoder, so maybe I'll look at it and explain what's going on while the CI is running. So a while ago I wrote this. Oops, it's off screen. There we go. This ABI decoder, which takes an ABI, buffer, or some ABI payload in a buffer and decodes it into a variable slot. And that's cool, but often what you want to do is not do that at all, but leave it where it is, and like with call data, or what we just did with the output buffer. And what we want to do is instead is lazily decode it. So like for every element in the ABI encoded payload, we generate a statement that's going to like load that stuff from the payload. I just want to be somebody for someone, oh, be somebody for someone, oh, do, 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 do. And of course, this already failed the lint. Anyway, so this is kind of neat because it doesn't actually do any decoding, it just creates a bunch of unwrap location things. Just unwraps everything. So that's kind of neat because it even works for like storage, call data, and it's like pretty generic. We don't have to make any extra special things. Lint failed, undefined name. These could be problems. Okay. Let's see. From Vyper.avi, codegen.avi, import all this stuff. We want to import all this stuff. Oh, imported but unused. Let's do something about that. Okay, everything from here is unused. So let's just comment that out for now. Output size. What else is here? ABI type of and lazy ABI decode are not imported. Let's remedy that. Okay. Oi. Okay, I got rid of that. Force push that baby. Yay. Past lint. Incredible. in progress. Will this ever finish? Very exciting because we're going to see everything crash and burn. I'm getting notifications that the test failed. Or the lint failed, rather. Wow, that broke everything. Okay. You know what? It's probably not even compiling, so let's run the test suite, find out what's failing, and then here, I'll sing. Oh, never mind, we got our first batch of failures. Let's see where we got failures. Please send me an error message so I can look at it. Okay. Whew. Int attribute has no attribute location. What is this even failing on? What? This because it's really distracting. Import contracts dot bar as bar. View this thing. That's funny. Okay, great. We need to import stuff. Then foo.vy. And need to import bar as bar. And probably move this to that. Okay. Make foo.by. Really cross our fingers. Output type, output placeholder. And of course, it comes to bite me in the butt because I decided not to use the new context placeholder thing. So the solution is, of course, to turn this into an LL node so that it can have a location. Output pose, and then we're going to call output placeholder node output pose location equals memory. And hopefully that somehow works. Hey, at least it did something. Okay, so what we've got here is we're going to store at the address 0 the result of M loading whatever is at 416, which seems a little bit bizarre. That seems like an extra M load. Right? Okay, let's just see if that gets closer to passing the test. No way. No way. Okay, I hope that's just testing import ability and not the actual results, because I'm pretty sure there's no way this code works. Let's run it up the flagpole. On some GitHub actions. I guess we'll run it. We might as well run it locally, and then see what happens. And we can start looking at any errors that pop up. There, we got a failure. Let's see. Assert. This messed up number is equal to 1. Obviously it's not. Probably because we're reading garbage memory. Okay, let's just see what code this generates, and then we can try to debug it. Oops. Foo.phi. Yeah, see, we're like mloading the result of an mload, but what we really... I don't understand why command not found keeps stopping unexpectedly. Anyway, got almost everything right, but why is it... Oh, because we're mloading the result of the output placeholder. Output placeholder. I want to see what calls this code. Oops. Okay. Get external contract call output. Oh, there we go. So sub equals that stuff. That's the stuff we saw in the output. And then we return this thing. Oh, and then of course when we try to unwrap the location, we get that. So I think that removing the location on that buddy will fix our problems. But I think something is still going to be wrong about this when we try to return a multi thing from here. Maybe not. Not if it calls make setter. Make setter will work. I think there's the point in the session where my computer is overheated and so nothing runs in any sort of reasonable time. See? Encoding overloaded. Consider something or other. While we're waiting, might as well kick off the CI. And this looks more or less okay. The real problem is that what we're gonna do is we're gonna do like a make setter, but this has like, this is gonna have like a seek in it, and then it's gonna return a stack item. But what we really want to do is like move this seek out of here, and then move the make setter inside here so that it can see when we have a a little multi-value thing. But hey, I think we're making progress. Test external contract definition alias.